So my position is I'm an associate professor, and I'm also head of the section of environmental engineering, of which one of the key areas is emissions. I do teaching and I do research, and I also do advisory service to the Danish ministries of environment and of food and agriculture. I'm also involved in developing test protocols for documenting emission abatement technologies for agriculture, and also approving tests of environmental technologies. One of my tasks is to ensure that the tests are following the protocol, basically. We are not certifying the technology, but we are assuring that the documentation is done according to the generally accepted standards. It became clear that measurements based on optical techniques can provide higher specificity. It is a challenge because these emissions are quite complex. When we're measuring ammonia, we're not only dealing with ammonia, we have volatile organic compounds in the air, we have dust and methane, CO2, and so on. So it's really important that we measure very specifically the target compounds. We could see that some techniques that have been used in the past were not appropriate, and we were looking for more specific analytical techniques, especially those based on laser technology. Are quite appropriate and has these very specific detection. We wanted to go in that direction. One of the providers of such equipment is Picarro. So it was quite obvious that we would need to get hold of Picarro instruments and see what they could do and test them and see that they actually could provide the quality we were looking for. So we did that, focusing first on ammonia and testing, for example, cross interferences, which we know was a problem with other techniques. So that's how we got into this and started using Picarro instrument for this type of research. And we can also see that the instrument has the sensitivity required not only to measure emissions from barns where we have relatively high concentrations, but also measuring emissions from fields and storage facilities where the concentrations are much lower. We have to measure downwind from the source and be able to detect small concentration differences. And with the high sensitivity of cavity ring down spectroscopy, we could see that we can achieve very useful results. Ammonia has actually a range of environmental and climate-related impacts. It causes ammonia emissions. Ammonia will be deposited again after emission, and that affects the ecosystems, contributes to the biodiversity challenge that we see basically all over the world. It contributes to eutrophication of aquatic ecosystems. It contributes to particle formation, so it affects people's health. And it is also what we call an indirect greenhouse gas, because ammonia, when deposited, some of the nitrogen is converted into nitrous oxide, which is a very potent greenhouse gas. So there are actually a number of reasons why we should be concerned with emissions of ammonia. And this is quite high and has been for some years on the legislative and political agenda. And throughout Europe, countries are committing to reducing emissions of ammonia. And here in Denmark, we have a very ambitious target to reduce ammonia emissions. Therefore, we also need to develop strategies and develop technologies that can achieve the mitigation without affecting the production. It is part of the green transition, you can say. We have the greenhouse gases, the climate, which is a big driver, but ammonia is also very high on the agenda, especially I think here in Europe and in those countries where we see intense livestock production, because livestock production is very much the major source of ammonia. So it is high on the agenda and really a key part of the green transition of society in general and of agricultural production in particular.